All right, in this lecture, let's start going over server-side attacks. Now, the first thing we want to go over is code injections, specifically SQL injections. Now, SQL injections are very still, just like XSS attacks. There's a lot of servers that are vulnerable to these type of attacks. And again, there's a lot of books and resources when it comes to SQL injections. SQL injections have been around since pretty much forever. And pretty much what people have found out is that because of the way forms are, we're not even talking about the web at this point. All we're talking about is clients and servers, okay? Now, on the server side, because usually the way code is written, and sometimes since it's not sanitized, remember we talked about this in previous videos, the server is kind of vulnerable to the same attacks that we were discussing previously on the web client, okay? Now, the difference is that if you can execute, or if an attacker can execute some type of code on the server side, it's a lot more dangerous because you actually do have access to the shell and to the terminal, right? Because you're just already on the server. So there's not going to be if an attacker is able to execute code on the server, then at that point there's not all the security features that the web has, right? Because it's kind of implied that if you're writing code on the terminal or on the shell, then at that point that you have access to that server. Okay, so again, that's kind of why XSS attacks versus code injection on the server side, which is like SQL queries. And again, remember, this is stored. This is the difference also between stored XSS and reflected XSS. But in this lecture, where we're going to be going over the attacks are more when something gets executed right on the server. Okay, so let me just show you something really quick. I'm going to come over here, and we're still working with the same server. Okay, I added kind of a new script down here. And all this is going to do is it's going to concatenate a file. So I've created a file over here that's just some lorem ipsum, nothing really special. So let's go ahead and see what happens when we output that file. So again, what we get, it's the echo back on the server. Okay, and that's what we get on the terminal here. Now, as we can see here, we're just doing this pretty naively. And what we are doing is we're saying, hey, whatever that as the second input, whatever we're getting as a second input, then serve it. But let's go ahead and see, let's say that the user input, remember, we've been talking about user input, and the way we should think about it is that pretty much the user can input anything into any form, okay? And especially if there's a form or if there's something that's going to get sent to an endpoint on a server, then we can't expect that the user is always going to behave as expected, okay? So we kind of have to defend against all these things. So what I'm going to do is imagine if a user put in not just file.txt, but then they also typed in ls, okay? And then what we're going to get now is actually output it the whole folder structure of the server. And that's, that could be pretty detrimental because it's not just that they can do that, but they can do things like RMRF, and then delete the whole website, the whole database. Let's just do something fun here. So if you really want to freak people out, here's a good one. Say hello world.
Hello world.
So there you go. And again, it spits out the regular file.txt, but then the attacker executed another command. Okay, so this is kind of what we want to go over in this lecture. These type of attacks that are executed on the server side. Okay, now I'm gonna go ahead and close this, and then I'm gonna start up a server. So we're gonna go back to the client now, and let's begin over here with this same type of attack, and let's see how it can affect us on the browser side. Okay, so if like I said, what we're gonna do is the same thing here, and actually I'm gonna go ahead and for now, let's go ahead and do the same thing, but we're going to send back to the user the output, okay? All right, let me see, do I need to actually, yes, I'm gonna comment this out because then I'm gonna show you the defense against this. But first, we're just gonna execute the attack now on the server side, on the client side, okay? So let's go ahead and let's just start the node server. Perfect. And then let's go to this endpoint over here that I made. All right, so now we have a file viewer, okay? So let's say that we kind of have the same thing that we were doing before. Now, the only difference is, so we're going to get a query coming in on the file name. And then the standard out that we're going to get is we're going to get a child process, and we're going to execute that same command. So essentially, imagine that the user is having this, imagine we have something like Dropbox or something, right? But we're doing this pretty naively. And then the way that we wrote that code on the server side was just to output whatever the file that the user looks for. Then we just want to give that file back to them, right? So we just want to show them that file. So let's go ahead and do that, and let's see what we get back. So I'm gonna put here file.txt, and what we should get is the same thing, right? So now again, it's just the same thing we're running on the server, but again, now on the client side. I'm gonna refresh this, and then let's see if we can actually access from the client all the server files, and then see if that server actually outputs the whole file structure. Instead of just doing ls, let's go ahead and write on the file viewer with the flag R, so that way it's recursive. And let's see if we can actually get a whole file structure. So like pretty much the whole buffer should get filled out here. And there you go. That's kind of our whole application, right? So if someone can get access to this, and again, you know, as far as we know, there's still a lot of sites that are vulnerable to this type of attacks. And this is, you know, one of the best ways to check against this stuff is just knowing what the SQL commands that can be executed on that server are. And, you know, if you're a developer or if you're a penetration tester, then these are the type of stuff that you need to be guarding against, okay? So as you can tell, an attacker was able to execute a command on the client side, and the server kind of gave them. So what we expected was a user just to put in a file that they wanted back, right? But again, since we allowed that user to just type in anything in the input, at that point, we're kind of opening up ourselves to all these type of attacks. And, you know, an attacker now can see kind of our whole directory structure. And again, if you have any files here, like a database or something, then the attacker can, at that point, know where your database is located. Knowing where your database is located can also give the attacker then access to, you know, doing different types of attacks. So now they can target your database, they can target some information. And, you know, again, it's just, it's an entry point, but it's an entry point that exposes the server to pretty much any other attack that the attacker can execute at that point, okay? So, all right, so now we have that. Now let's go to the bank application, okay? And I'm going to, now before we move on to the next exercise, I want to show you one last thing, which is the defense for this. So what you want to do is, one of the ways to defend against this, especially on the server side, it's, so let's see here. So we're going to do the same thing, right? So instead of child process and executing it synchronously, what we're going to do is we're going to spawn sync, okay? Which is, again, in every in every language, this will be a different command. So just figure out which one it is. We're writing in JavaScript. So we're going to spin up a new, we're going to spawn up a new process, and we're going to say, hey, we want to run these two things separately, okay? On one end, we're going to specify what it is that we want to run, so the command. And then on the other end, we want to say, this is what you should run through that, okay? So again, now, what we want to see is how does this defense guard us against the attack, okay? So let's try that same attack again. Yeah, I'm going to refresh it just to make sure, and then I'm going to try the same attack, okay? And now what we get back is cat file text lsr, no such file or directory, right? So what are we doing? So we're saying, hey, this cat command is going to get run, but then it's going to concatenate kind of the whole thing. So you see what we're saying. We're getting a no directory error because this whole thing gets sanitized together, okay? So it's kind of saying this thing called cat file.text lsr, that doesn't exist, okay? Because again, it really doesn't, because it's running the two commands separately. So at this point, then we get the expected behavior, okay? And someone couldn't just string along many commands and then execute arbitrary code on our server. But still, if we just type in the expected file.text, then it'll spit out the correct output. And that's exactly what we expect, okay? So again, this is just a way that someone couldn't just string along, right? So they couldn't terminate our process, and then after terminate the process, then run another command, right? That's kind of what we want to guard against. And then that's kind of defense. So what we want to do is, again, On JavaScript, it's we're gonna spin up a new process, and then what we're gonna do is, since we have two processes kind of running, we're gonna say on one end what the command is that we want to run, and then on the other end kind of the files where what the input is. Okay, and now in this case we're getting the input, yes, from a form, but you can imagine this can come from anywhere. Okay, but at least it guards against like I said, being able to string along many commands and then having the server naively just executing these commands. And again, it just exposes us to a lot of vulnerabilities when someone can just execute arbitrary commands on the shell or the terminal. Okay, all right. So let's move on. I'm gonna start the server on port 4000. Okay, let's leave it there. And now what we want to do is we're gonna start up a SQLite database. Okay, and now we are going to go over SQL attacks. Now, SQL attacks are very similar to what we just reviewed. Okay, so we've already seen, again, on the client side, we've already seen cross-site scripting attacks, and this is again very similar simply because we're allowing a user to have input, and anytime we do that, again, we open up ourselves up to these type of vulnerabilities. Okay, so it's not that user data can be trusted. It's just we have to guard against the behavior that we want to see and not just open up ourselves completely to just running arbitrary code. Okay, so the code that the interpreter processes is a mix of instructions written by the programmer and then the data supplied by the user, right? That's kind of how our programs work, right? It's some of it's static, but then also some of it is dynamic, and that's a good thing, right? We want dynamic websites because we do want to create those tailored experiences that everybody likes. We kind of want to have be able to create websites that can be can take in user input, and based on that user input, spit out different outputs. But again, so our websites are a mix of these inputs that are static and then these inputs that are dynamic. Okay, so we just have to kind of deal with that. Now, when the attacker supplies input that breaks out of the data context, that's kind of what gets us what can get us in trouble. Okay, and that's usually how these attacks will happen, right? They'll try to break out of the context itself, and like you saw, they have to for this example, in this attack, what we did is we terminated a process. So once we terminate that process, again, we're kind of going outside the scope, and then we're starting a new command, right? So we're terminating one command and then starting a new one, and that allows us to end the execution of one thing and then continue the execution of the next thing, right? So that's kind of how that attack is run. So again, the attacker input gets interpreted as program instructions, right? So because we're writing directly to the server now, right? So this is directly on the shell or the terminal, and at this point, anything that that attacker can do, if it's not sanitized correctly, then it will run. Okay, it will run on your terminal. It's just a server. It's like being, again, at that point, it's complete access, right? And this is normal. Like, sometimes we do expect this behavior. If you're tunneling over SSH, then that's exactly what the behavior that you expect. But it's only when we give access to the user input, and then we're not getting the behavior that we expect. These are the attacks that we can open up ourselves to if we don't sanitize the code correctly. So command injections. The goal of these attacks usually are just to execute arbitrary commands on the host operating system via vulnerable applications. So again, this could be in the form of a form. This could be, we've seen it through XSS attacks. Again, but that's kind of the goal, okay? So the command injection attacks are possible when an application passes unsafe user supply data. So again, through forms, cookies, HTTP headers, anything, to the system shell, okay? And this could be even stored XSS, right? So if it's stored at some point and then at some other point, it's going to get queried back, but it's going to be processed first and foremost by the server, then given to the client. Then at that point, when it's actually being rendered and parsed by the server, at that point it can become vulnerable, right? Okay, so command injections. That's kind of the what we just went over, right? This is the attack, and this is kind of the naive way of doing it, which is just run the whole thing as it comes in. And although we're interpolating here this data, and what we expect is the user to just put one file at a time. That is the expected behavior. We can see that they can obviously write as many commands as they feel like, and end each process and then call another process, and there's really nothing stopping them. So again, the way we stop against those attacks is we're gonna spawn two processes, and in one we're gonna specify the command that we want to run, and the other the inputs, right? So now because we have these two things separately, we're gonna run one on one side and then the other one, and then kind of merge them. But we're not gonna merge them, like we're not gonna run it all at once. We're gonna merge them, okay? Instead of running it all kind of like in successions. So that's kind of the defense against that, okay? So SQL. Let's talk a little bit more about SQL injections. Pretty much, this is we're gonna write a query like this. Okay, again, it's pretty similar to what we just did. So what we're gonna do is we're gonna rewrite our bank application that we've been working on. We're gonna query it, okay? But now we're gonna be querying from a real database, and we're gonna be using SQLite instead of the object databases that we've been using. So I can showcase some of the attacks and how they can be performed, and again, how to guard against some of these vulnerabilities. So let's say we have this type of code written in our server. Select all from the users table where username is username, right? That's kind of the template that we're gonna go with, and then we're going to kind of show all the attacks against this template. How this one single line of SQL can become a vulnerability and a vector space for attacks, okay? And then we're gonna parse the results, and then we're gonna return the results, okay? Now let's go over a few examples, and then we're gonna see it live, right? So this is the template that we're gonna be using. So let's say the user just inputs something regular, right? In the bank application, if you remember, let me go back to it. So now that we're in the bank application, again, we expect the user in this form just to input user and then their password, right? That's kind of the expected behavior. So they can just put in John, and then again, we can see that this is working. Let's just log in into Alice's account for a minute, and then we're gonna submit this. So everything is working as before, right? So we can log in, we can log out, but the difference being is now we've changed our login endpoint. So that in order, instead of getting the username from this object that we created here, we actually created an SQL database. Okay, so now we're actually going to be querying a real database. Okay, and then we're gonna see that the attacks that can happen once we have stored data on this database, right? So okay, let's go back. So now again, the expected input is just their username, right? And then from that username, we're just gonna say, hey, select from the users table that we just created the username that matches John, right? And then the database will return to us kind of that user. All right. Now let's look at some of the things that we become vulnerable to. And again, this is going to sound very similar to XSS, but now remember, this is kind of more a stored approach, and these things can kind of be executed in real time as well. Okay, so now what happens if the user doesn't just put in John, but they put in John and then the double quote? Okay, so what's gonna happen is that this is one way to end an execute command, right? So this is one way that that the attacker can end the process and then run extra commands after that double quote. So right, because they're kind of so at this point, if you remember, we're in this template. This is the first double quote. So then our code is gonna run here, and then they're going to early terminate the process, and then they can run kind of anything after this. Okay, so that's kind of the vulnerability right there, right? So if we're just kind of have this template, it opens us up to a double quote ending the process early, and then running multiple attacks, multiple commands at the same time, and then that's an attack vector that we have to guard against. So let's say again, same template, right? But now they don't just put in username John, they put John double quote and then I'll double dash. So in SQL, this is a comment, right? So what we're gonna say is, anything after this, we kind of don't want to look at it. Okay, so again, this is the way that we tell in SQL, the way we write comments is this, and we kind of saw some of this stuff in the XSS videos. Okay, so the resulting query is going to be something along these lines: select from the users table where username equals John double quote and then double dash. Okay, and then the double dash kind of opens us up to multiple processes being run at the same time. So then let's look at a real attack vector that can happen. So again, same template, right? But now what are we doing? So imagine this is the input that the user puts in. The username is John. Okay, early termination. So we see an early termination here. And then in SQL, they write or. So if you don't find anything with the name John, then find something where it equals 1 equals 1. So it's essentially like writing John or true, right? So of course it's either going to find John if that exists or not. It doesn't really matter because the next command, it's or true. So it's like running a while true loop on the client side, right? So if we write on JavaScript a while loop that's just a true loop, then someone can DDoS your server, right? Because then that never terminates. This is kind of the same thing, but in SQL, right? So it's gonna say run, try to find a user called John, and if you don't find it, then see if anything is true, and then of course we're gonna pass it the value true, which is does 1 equal 1, and of course that will always equal true. So then that will pass, and then we're gonna say this is an SQL comment, so that way we don't have any other issues with terminating the process early. And then the resulting query from that from this input will be the following: select from the user's name anything that's John or something that equals true, and of course we passed that input ourselves, so of course it's going to equal true. Okay, and then that way we can see here that they don't even have to actually include the name. They can just put early termination or true, and then the comments, and of course 1 is always equal to 1, so that's always true, so that will pass, and then then they have kind of access to the database at that point as well. Okay, and then let's see here if there's another one. So yeah, we'll go over this one, but let's try to see how this attack works. So let me come over here and let's try a few things. So first, let's try to just log in as so remember we have to type Alice, and again, if we input a wrong password, okay, we're gonna get a fail. So everything is working as expected. Okay, so now let's see what happens if we type in Bob, early termination, and then double dash. Okay, so let's see here, and then I'm not gonna type in any password. Okay, so we're just gonna submit this, and there you go. Right now we are inside of Bob's account, and we can kind of see, kind of their whole account, right? So at this point, they can do a transfer, they can do whatever they want, but essentially they're inside, right? So at this point, you're kind of screwed. So there you go. That's one attack, and that's what we were looking at before, which is again, we wrote the username, right? Then we terminated because of the way that that this query it's written. So it's written pretty naively, and so I'm saying, hey, select from the users table where username is username. So whatever that username is, right, that they put in this form, that's what I wanted to match, and password equals whatever the password is, right? But we're never gonna get to this part of it, right? Because I'm gonna terminate it early in the attack, right? I did an early termination, and then I did a double dash. So I'm saying, hey, just ignore the rest, right? And then that's kind of what I'm the query that's going to be executed on the database itself. It's going to say, hey, just find me something that's called Bob, right? And then this rest of the query is not going to run. So even though it's written on the server, because of the way that the user input was written, then that's never going to run. So it doesn't matter that it's there on the server, and that's kind of what this attack is showcasing, okay? Now let's write the OR attack. Okay, so now we saw that we included Bob. So that's great. That's great if the attacker knows the actual username. But what if they don't? Okay, can they actually get into any account? Well, this attack will show that they can. Okay, so now we're showing, match whatever, which is really nothing. Okay, so match no username or 1, right? So we don't even have to know the username. Let's see if we can get into the database at this point. Well, there you go. Now we're in Alice's account. So what it's going to do actually, So because of the way this query is written, so when we do db.get, the get command on SQL returns kind of the first user. So again, that's just kind of the draw of the luck, essentially. But at this point, it's just going to return the first user. But still, we're able to get into a user's account without knowing even a username, right? That's pretty scary. But again, this is what happens if we don't sanitize our code correctly. Let's also so let's see if we can do something a little bit more mischievous here. So now we're not going to input any username because we really don't know anyone in this database, but we do know what we're interested in, right? So what are we interested in? Hey, let's see if in this database try to find me anyone, right? So first and foremost, since we know it's going to ask for a username, we're saying find a username or, right? Or, we're not even going to input anything. We're going to do an early termination or an account that has a balance over, a certain number. Okay. At this point, what we want to do is we want to enter an account that has a large balance, right? So large balance. So let's go ahead and submit that. And all of a sudden, we are inside of an account with that has millions of dollars, and the attacker at this point can just start doing a transfer, and you're pretty much screwed, right? So this server at this point is kind of screwed, and the attacker has owned it. Okay, so again, that's kind of running arbitrary SQL commands on the server. But here's another thing. So let's try another attack here. So we're going to do an early termination, okay? But then we're going to write to the actual database. So imagine this. So imagine now we're going to update the users table, okay? Update the users table and set the password to root, where the username equals Bob, right? So imagine if first and foremost we're going to find out, right? So imagine if we ran the previous command first, and then we find out that that account's holder was named Charlie. Okay, let's just figure that out. And then we're going to say, hey, we're that account because we already know that, right? So the attacker was able to get in. They were able to see that they got another piece of data. Now, with that next piece of data, what they're going to do is they're going to update, because now that they know that this server is vulnerable, then they're going to update the server, right? Because now they know they own the server. But imagine if the user has this, so imagine if the server has another vulnerability. So which is the execute vulnerability that I showed you for. And again, there's no sanitization on it. So they're pretty much going to, let's say they have an audit log. So like they have some audit server where pretty much they're auditing all their SQL commands. So sometimes we do this just to figure out what are the functions that are running that are taking the longest. If you have a lot of things, like especially like with machine learning and things like that, you want to optimize kind of those functions, right? So sometimes you just have an audit server, and what that audit server does, it's just kind of times when a process starts and kind of when it finishes, right? And then that way you can kind of see, hey, what's taking the longest, and once you know that, then you can optimize it in any way that you see fit, okay, or whatever. But it's just a way to see kind of either you need a new architecture or to optimize it, the function itself, or any of those things. So this is actually quite normal, just to have an audit server, especially for bigger systems, right? So imagine that this command's here, and again, what we're gonna say is, hey, insert into the logs database the values for login attempt. So anytime someone tries to log in, we want to have that being logged into the server that we're kind of like having as an audit server. Okay, and I'm gonna go ahead and submit this. Okay, so we got an error, right? So we're not able to submit it. But let's see what ran on the server side. And on the server side, although we got a fail, right? So on the client side, and maybe the attacker knows this. So like, the attacker's not necessarily interested in getting in at this point, but they're interested in updating a record in one of the databases. Okay, so like I'm just trying to show you kind of what are some of the vulnerabilities, and then how to defend against these attacks. Okay, so that's the vulnerability. The vulnerability in this case is that because of the way that the execution function is written over here, we kind of have given the attacker arbitrary access to our server. Okay, now they can, again, just because we have access to one of the databases, we can see that through there we gain access to the other database. Okay, and then although we got a fail on the client side, let's go back now. Okay, and let's try to log in. Okay, now this time it's that other user that we just changed their password, and let's log in with the password that we just changed it into, and let's see if we can log in. All right, so now I'm just going to try to log in into this account with the new password that we just created, right? We just updated that table, so let's see if we can get in. And there you go, just like that, we were able to update that table. And again, remember the first command we ran got us access to the account holder's name, and then once we had the account holder's name, we were able to change the table to whatever password we wanted, and at that point we were just able to get in, right? So that's again pretty vulnerable. So that's those are SQL injection attacks, and then in the next lecture I'm going to show you the defenses against this, how to sanitize them, and how to protect yourself from these things, because again, although it would suck for sure, especially if you have a bank application, that someone can do this, but again, this can happen in any other type of account, and because again, as more of our identities are online, then when someone has access to one of our accounts, it could potentially open us up to them having access to many other accounts. Okay, and that's why, again, you want to use maybe a password manager. That's probably a great defense, because then the user won't be able to so easy get into, if they get into one account and maybe that account is vulnerable, then they won't be able to get into every other account, right? So, and a password manager allows you to create really protective passwords without you having to remember them all. Okay, but even if you do, but let's say you're the developer, then what I want to show you is I want to show you how to defend yourself against these attacks and defend your users against these attacks, because many times, again, like, this can happen for any number of reasons, and it's not that maybe we have malicious users, but this could even come sometimes as mistakes and things like that. Okay, so we want to make sure that that doesn't happen, because stuff like this can also happen, and this could be a huge it's really hard to recover sometimes this data if you don't have any backups or anything like that. But you can just run this command and then drop the table users completely. So I'm gonna run it on that, and although it failed, let's see over here. So we just dropped that users table. So as you can see, when I open up my my SQL database now, if I try to see how many tables I got, that users table, that completely got dropped, right? So that completely got deleted, and that sometimes can be even worse if you don't have a backup of your table. I'm gonna go ahead and also drop from within the client side the logs table. Let's come over here. Yeah, so I'm gonna drop again the logs table and then just delete it, right? So an attacker can actually let's just submit this, and then I'm gonna go ahead and check over here. So if we come back and we refresh, we see that now we have nothing in our database, right? So like, it's been completely wiped out. So again, that sucks. So if we open up ourselves, we can see how, like, little by little, an attacker can, from something very simple, right? Like we started with, from a file viewer, right? They can then just run arbitrary commands. So again, let me just make it vulnerable again, because now we have that defense. But imagine that it was written in this other manner where just it's not sanitized correctly, and then code is being allowed to run arbitrarily. Then the attacker can essentially get a full picture of of the server, right? That's kind of it, right? And then in here we can probably see that there is a file called db, right? And then all these files, and then they can just start performing the db.file right here, right? So they can definitely see that we have a database. And then after that, we can see all the commands that they were able to run in this database from simple commands like getting into, well, I just dropped all the tables, so there's no users. Let me go ahead and remove that. And then let's restart the database. Okay, let's open it back up. And then we should see that in the, so now we got our users back. Okay, so we saw simple attacks from, again, now the first attack, they were able to get access to a first piece of data, which is just kind of our whole directory structure. Okay, and then they're kind of able to just log into arbitrary accounts without really knowing passwords at all. They can run attacks that target special accounts, specific accounts that have a certain balance. All these things, right? Like, they can pretty much own our own whole server. So again, one way is, again, you want to have a password manager. You want to have like sufficiently double layered defenses. And I'm going to show you in the next lecture how to guard against these SQL commands on the server side once an attacker can potentially run shell commands or terminal commands. All right, so that's going to be important. So anyway, stick around and I'll see you in the next lecture.